Okay, so now that you have finished your Chapter 13 test, we want you to watch this video that's going to introduce the first topic for Chapter 14, our last chapter of the year. And the first topic for our second stat chapter is going to involve something called a two-way frequency table. So please have your notes out so that you can copy down the lesson as we go through it. So statisticians are often interested in how responses to two different categories could relate to one another. So some examples we want to think about, maybe we want to know how a person's gender would affect a profession they prefer. So gender would be one category, the profession they prefer would be the second category. Maybe we want to know if someone's hair color has any relationship to their eye color. So again, hair color would be one category, we would be comparing to eye color, a second category. And this type of data we summarize in something called a two-way frequency table. So the first thing we're going to do in exercise 1 is we're going to take a look at a table that involves a class of students that reported their hair color and their eye color in this frequency table. So what we want to do first is just to kind of complete it so that we have all the information necessary. So when I complete a frequency table, we just really want to look for the blank spaces. So the first thing I see is that I have a blank total box next to eye color for blue eyes. So I would just look, well, it's 3 plus 4 plus 1, so there's 8 total here for my blue eyes. I have a blank down here for green eyes, but it's in the category, it's in the column for black hair. So there's 9 people that have black hair, so 3 plus 5 gives us 8, so there must have been one person with green eyes that also had black hair. Then we want to look at blonde hair color. There's a missing space for people that have blonde hair and also brown eyes. So if we have a total of 7, we're missing 2. Red hair, the total is missing, so we just have to add straight down. 1 plus 0 plus 3 would give us 4. And then the overall total is missing. So the way you can get this is either add straight down in either of your columns for total. So you could add across your totals horizontally or add straight down vertically. Either way, you should be getting 20. Okay, so now that we've completed our table, let's answer some questions on it. So how many students have red hair? Okay, so I'm going to look at my table, I'm going to look for the total for just red hair, and the total here gives me 4. Okay, how many students have blue eyes? Now I'm going to look over at my row for blue eyes, and if I look across, the total here tells me I have 8. How many students are in the class? Well, that's the total that we found earlier when we added straight down or straight across our total column. So there are 20 people in the class. And then the last question has 2 categories. It's saying how many students had blonde hair and brown eyes. So now we're talking about 2 things. So blonde hair and brown eyes. Let me just come back up here. Blonde hair would be this category. And also having brown eyes, that would be from this row. So people that have both would be these 2 people. Okay, so that was a two-way frequency table. There's also something called a relative frequency table. When we talk about this word relative frequency, what it does is it compares the frequency count, so the number that we just had in our last chart, to the total number of observations. So in this case, our total was our 20 students. So we can express relative frequencies in fraction form, in decimal form, or in percent form. So you're correct whether you write it as a decimal, a fraction, or percent, as long as they're equivalent. Now, there are 2 types of relative frequencies. There are things called joint relative frequencies and marginal relative frequencies. So when we talk about the cells that are within the table, those are our joint relative frequencies. And the cells that are located around the table, or what we might refer to as our margins, are called our marginal frequencies. So let's fill in this relative frequency table, and then we'll point out again the joint as opposed to the marginal. So when we take a look here, our original values, I'm just going to start with blue eyes. We had 3 people with blue eyes and black hair, 4 people with blue eyes and blonde hair, 1 person with blue eyes and red hair. So instead of just writing the frequency, we're writing it out of the total. So 3 out of 20 people had black hair and blue eyes. 4 out of 20 people had blue eyes and blonde hair, and 1 out of 20 had red hair and blue eyes, which gave us a total of 8. Okay, well, there were 8 out of 20. So the 8 out of 20 here, if we want to just maybe do this in a different color, 8 out of 20 would be the marginal, because it's part of the margin, whereas the inside would be the joint frequency. So let's keep going. So brown, we would just take, we had 5 out of 20. Here we had 2 out of 20, 0 out of 20, and then the marginal, the total was 7 out of 20. Then we had 1 out of 20, 1 out of 20, 3 out of 20, and then the total was 5 out of 20. 9 out of 20, 7 out of 20, 4 out of 20, and our final total should be 20 out of 20, because that's our total. And I just realized something down here. All of these are also in my margins, so to make those blue. So everything in blue, everything in the margin is a marginal relative frequency, and everything inside in red is called a joint relative frequency. So what I said before about everything being able to be written as a fraction, decimal, or percent just means, okay, so 3 out of 20, if I type that into my calculator, I would get 0.15. So I could write 0.15 here in this box, 3 out of 20, or I could write it as 15%. I'm not going to go through and do every single one, but it just means that the 3 out of 20, the 0.15, or the 15% are all equivalent, and they're all correct ways of expressing a relative frequency. Okay, we also want to understand associations, or what we might call a trend within our data. So would a response in one category maybe tell us something about a response in another category? Is there some type of association happening? So these are called conditional relative frequencies. So that's when we're going to compare the frequency of something happening to one of our marginal frequencies. So those were our totals that we had in either the rows or the columns. So those are our outside frequencies in the total column or margin. So again, we're taking a look at exercise 2, but it's the same frequency chart we dealt with in exercise 1. But now we're going to talk about conditional relative frequencies. So if we read through part A, it says, what is the conditional relative frequency of having green eyes if you have red hair? So they wrote in parentheses, equivalent to asking what percentage of people with red hair have green eyes. So what they're saying to us right now is, okay, how many people that have red hair, which I can see here there are 4 people that have red hair, also have green eyes. So if I look at this, out of those 4 people, so that's my marginal frequency, that's my total, 3 of them have red hair, have green eyes and red hair. Okay, so we have 3 people out of the 4 total that have green eyes and also have red hair. So we could write that again as a decimal or a percent. These are all equivalent. Part B, what is the conditional relative frequency of having green eyes if you have black hair? Now let's take a look. We have a different condition. So if we have black hair, what's the conditional relative frequency if we have green eyes? So if we look at everyone that has black hair, there are 9 people, and of those 9 people, 1 person has green eyes. So 1 out of 9 people that have black hair also have green eyes. So you could write this, the percent, it comes out to be about, keeps going, or we could write it as a percent, 11.1% about. Part C, does it appear that having green eyes has a dependency, or maybe at least an association, with having red hair? Well, for this part, I would say yes. Because if you compare these numbers, 3/4, so 3 out of 4 people had green eyes when they had red hair. But if we think about just in general, how many people have green eyes, 5 people have green eyes out of a total of 20. So if we compare these fractions, 3/4 is much greater than 5 out of 20. So there's definitely some association here of having green eyes when you have red hair, or just in general having green eyes. And if it's a little easier, you could think about this in terms of a decimal or percent. This is saying 0.75 is greater than 0.25, or 75% of people that have red hair and green eyes is much bigger than just the 25% of people that just happen to have green eyes. Okay, for part D, last part of question 2, we're being asked, is it more likely that a person with blue eyes has black hair, or that a person with brown eyes has black hair? So let's go back up to our chart so we can take a look at this. So if we're talking about someone with blue eyes having black hair, there are 8 total people that have blue eyes, and of those 8 people, 3 of them have black hair. And then we're also comparing that to, well, how many people have black hair that also have brown eyes. So there are 7 people that have brown eyes, and 5 of them have black hair. So if we look at those as fractions, basically what we're saying here is if you have blue eyes and have black hair, that's going to be 3 out of 8. But if you have brown eyes and also happen to have black hair, that would be a 5 out of 7. So again, we can look at this in terms of the decimal. 3 out of 8 is going to come out to be 0.375. And 5 out of 7 is rational, but it comes out to be a decimal with a pattern. So if we continue to write some of the decimal out, we write a dot, dot, dot to show that we continue. We can see that 5 out of 7 is a much bigger number than 3 out of 8. So I would say here, it is more likely that a person with brown eyes has black hair. Okay, the last question we're going to take a look at says 52 graduating seniors were surveyed, and it was conducted to determine if there was a connection between gender of the student and whether they were going on to college. So they compared males and females, and then they also looked at if they went to college or if they did not go to college. So they're asking us this one question: what is more likely, that someone going to college is female, or that someone who is female is going to college? So the wording might sound like it's the same thing, but it's different because of the order in which it is being asked. So let's look at the first piece. What is more likely? So that someone going to college is female. Okay, so the first thing they said here is someone going to college. So I would look at my table and I would say, okay, how many people are going to college? So going to college, there are 29 people. So of those 29 people, how many of them happen to be female? And that total would be 13. So people that are going to college that happen to be female are 13 out of 29. And let's look at the other piece. What about someone who is female that is going to college? So now I need to look at this differently. I need to now look at the total of people, that are female that were surveyed. So there were 22 people surveyed that were female. And of those 22 people, again, 13 of them were in the going to college category. So now we're looking at 13 out of 22. So now we have to compare the fraction. Okay, so 13 out of 29 comes out to be about 0.4482. 13 out of 22 comes out to be 0.5909. So we can see here that it is more likely that a female going to college is more likely than just going to college and happening to be female. So if we write that out, female going to college, so that was our 13 out of 22, is more likely Then going to college as a female. And that was our 13 out of 20. So at this point, what I would like you to do is to take out the practice. The practice is two-sided, just like the notes, and I would like you to take some time to complete the practice. Now, this should take you at least 10 minutes or so. This is most likely something you will work on at home after having watched the video in class. I do have the answers on the smartboard, so I would like you to pause the video, complete the practice, and then I will put the answers up. Okay, so here is the first page answer key. So I'm just going to scroll through it, take a minute to check your work. And here's the second page. And at any point, if you need to go back, just pause the video and look at the answer key so you can check over all of your work. Okay, at this point, now that you have completed the practice, completed the lesson, and checked over your practice answers, I would like to advise everyone that if you have any questions on today's lesson, to please come into Extra Help Monday, Tuesday, Thursday, or Friday mornings. And we will spend time going over these types of questions in the homework assignments each night throughout this chapter. So thank you for watching, and please rewatch any part that you had trouble with.